A spacecraft cruises silently through the outer spiral arm of the Milky Way. These voyagers from lands far away aren't in a hurry, travelling at just 60,000 miles an hour, a crawl by cosmic standards. But they've kept their pace for 1,000,000 years, journeying by several thousand star systems over a distance of 100 light years. And each new star system they pass, they scan, searching for the perfect combination that they're looking for. A lifeless new planet around a young, yellow sun. Circling in on their long sought-after quarry, passing close by to the planet's surface, they deploy their ancient payload. Dropping, shielded through the atmosphere to land on the surface, disgorging its contents. Inside is a 1,000 kilogram payload of bacterial samples. 100 different types, each varied and suited to a different environment. A few immediately perish on the surface of this new planet, the chemistry and conditions all wrong. But the ones that survive find a habitat ripe for the taking. They not only survive, but thrive, quickly moving to colonize the surface. And they evolve, adapting to new niches, exploiting brand new environments. Over the next 4 billion years or so, while the yellow sun brightens overhead, they evolve into ever more complex forms. Until eventually they evolve into conscious creatures, beings that are self-aware, with culture and philosophy. Science. Mighty civilizations rise and fall, eons and golden ages coming and going. Until finally, for the first time, these colonists can give their home a name. Earth. This origin story might sound like science fiction, but it's a real, credible scientific theory first proposed in the 1970s by one of the discoverers of DNA, Francis Crick. It's just one of the options for the phenomenon known as panspermia, an alternative extraterrestrial hypothesis for how life on Earth began. Panspermia, a term stemming from ancient Greece, directly translates to all seeds. It describes the idea that the seeds of life spread by distribution throughout the universe, either accidentally or manually driven, germinating and spreading wherever it finds a likely host planet. It's more than a fringe theory too, and not considered pseudoscience. Panspermia is something scientists have been coming back to for hundreds of years. In 1903, it was Swedish chemist Svante Arrhenius who first suggested that spores could be driven across the expanse of space by the pressure of solar radiation. And by 1957, it was again suggested that life on Earth came from another planet, as an aggressive infection. An alternative concept was proposed in 1960, that Earth life was the byproduct of cosmic garbage, organic detritus left behind by an older, much more advanced civilization. And as we have learned, in the 1970s, Francis Crick entertained the possibility of intentional, directed panspermia. It's something we can imagine doing ourselves to seed other planets with the template of our own ecosystems. Finally, by the 1980s, eminent mathematician Chandra Vikram Singh went so far as to suggest that viruses might have rained down from interplanetary space, and thus responsible for brand new epidemics on the one hand, and boosts in evolution on the other. Theories of panspermia find credence in the evidence from the early Earth. By all reckoning, our planet's first half-billion years or so were a violent, tumultuous time. It was a truly inhospitable place for life to begin. And yet, begin it did. Remarkably rapidly after the end of the hellish Hadean. Certain compounds, like sugars and amino acids, require the conditions of a solar nebula to form, and are delivered to a planet's surface by the relentless solar wind. Undoubtedly, some of the ingredients for life did come from space, in what is sometimes known as soft panspermia. In 2004, the Stardust mission flew a special, sample-collecting gel through the tail of a comet and returned it to the Earth. Inside that gel, scientists found amino acids and other organic compounds essential to life. It's likely that these cosmic chemicals accreted along with the Earth and have been raining down gradually ever since. But although modern scientists can begin to identify parts of the molecular puzzle and describe how life could have arisen from the basic building blocks available at the planet's surface, that puzzle has yet to be fully solved. The true origin of life on Earth is still a mystery. So then it seems almost natural to ask, could it have originated somewhere else? Could microorganisms have been seeded on the Earth not long after its formation, either intentionally or accidentally? The directed panspermia posited by Crick is certainly possible. Our Earth is just 4.5 billion years old, but the universe is more than 3 times as ancient. Star systems that formed early on in the universe's history could host civilizations much older and more advanced than our own. So while we don't yet have the technology for an interstellar seeding mission, it's conceivable that such a technology could be developed with time. And yet with only one living planet that we know of right now, evidence for directed panspermia is lacking. Instead, passive panspermia is a hypothesis we can give substance to, with our knowledge of physical processes ongoing in the solar system today. There is evidence that life could accidentally have been seeded across the cosmos. For a living being to travel from one celestial body to another, they must survive 3 trials: escape, transit, and delivery. First, they must escape their host planet. while we are firmly rooted to the ground, or the lower layers of the atmosphere at least, microorganisms are more flighty. Small enough to be moved by atmospheric forces, moved upwards by thunderstorms and volcanic eruptions. They can travel right to the top of the atmosphere, where it's assumed it's easier for them to be whipped away by the solar wind. Beginning what could be a near endless journey through the heavens. Or they could escape by the catastrophic forces that jeopardize life on the surface. Large enough asteroids can shatter surface rocks, scattering them upwards out into space. If those rocks contain microbes, then they could very well become tiny spacecraft, manned by a bacterial crew. The next challenge is to survive the journey through space. A cold, dry vacuum awash with deadly radiation, space is not a friendly place for life. And the sheer distance between planets, a near endless void of inhospitable wasteland, means that any bacterial travelers face a long journey. Depending on their heading and destination, the trip could last millions of years. Over the last few decades since humanity took to the solar system, scientists have conducted plenty of experiments on board satellites and spacecraft to see how well Earth's bacteria could survive in the vast reaches of space. It turns out that many microbes are able to protect themselves against the cold and dry conditions in a primitive form of cryostasis, as inactive spores. But UV and cosmic radiation remains a threat, even to dormant spores. Having the power to break and distort the genetic material inside the cells, killing them outright or mutating them beyond recognition. So, some shielding is needed. And if not in a specially designed spacecraft, then a simple rock will suffice. The radiation cannot pass far through solid rock, so microbial passengers contained within could weather the cosmic storm. But these interplanetary voyagers have one final challenge before they can become the colonists of a new world. They must survive the landing. Meteors raining down on Earth experience intense heating and a shock of impact that is enough to melt solid rock. Could a simple life form possibly survive? This too has been tested by modern scientists by shooting bacterial samples through a powerful air cannon. The survival of these spores suggests that, under the right conditions, microbes could indeed survive a landing, encased in their protective rock armor for 1 million years. And when the dust finally clears, the new world is theirs to call their own. So, evidence on Earth suggests that life could indeed have survived a trip through space. But evidence that it actually did, and this is how the seeds of life were delivered to Earth almost 4 billion years ago, is lacking. The potential evidence has simply been lost to the mists of time. To plate tectonics and the recycling of the Earth's surface. Some would argue that this is a moot point anyway. If during the first years of our world, some 4 billion years ago, living beings arrived on Earth from another planet, it only shifts the question of the origin of life to a different location. And one we know even less about than the early Earth. Life must have begun somewhere. But Since we still don't have all of the answers for how life got started here, then another planet, another environment could hold the key. Another planet could be host to some factor that makes the spontaneous generation of life much more likely. And today we are discovering thousands of new exoplanets in orbit around alien stars. For the first time, we can probe these extraterrestrial environments in search of answers. We may yet find Francis Crick's advanced civilization as gods creating species in their image throughout the cosmos. But until life is found on another planet, we will never truly know whether we are children of the Earth or of the universe.